So before we look at example cases of law of cosines, let's review what we know so far. Below I have listed some possible different angle side combinations for triangles that you may be familiar with from geometry. Now there are 6 different combinations here. Previously we have seen that there are 3 cases, which are angle, angle, side, angle, and side, angle. And that's when the law of sine can be used to solve non-right triangles. However, we skip the side angle because this was a special one called the ambiguous case. So again, we are going to ignore the last one. Therefore, we only looked at examples of angle, angle, side, and side, angle using law of sines. Now, the bottom 3 are the other cases in which 3 pieces of information of a triangle can be known. However, we're going to ignore the triple A, and that's because with just 3 angles, we will never be able to create one unique triangle. And you can relate this idea to similar triangles. Then the question is, can we use the law of sines to solve the side angle side or SSS cases? And the answer would be a no, because in either cases, no angle opposite a known side is given. Then that's when we use the law of cosines to solve the triangles. So in this next slide, I have listed the law of cosine formula, which can be written in 3 different ways depending on which variable you start with. This can be used when you're not given enough information about the triangle to solve with the law of sines. And those are when you have triangles with just the 3 sides, so side, side, side. That's one case when you should use the law of cosines. And another case is when you have side angle side. That's when you have 2 sides of a triangle with one included angle. So let's take a look at some examples. In this first example, we're given one angle and 2 sides. And when you're solving, when you're using law of cosine or sine, you always want to start by drawing the diagram. So let's draw a non-right triangle. And it doesn't matter which angle you label as A, B, or C, but I am going to label this A, B, and C, with this being 42.3 degrees for angle A. Then to find the opposite side of angle A being the lowercase a. Opposite of angle B would be the side B, 12.9 centimeters. And same thing for side C, opposite of angle C. And once you have drawn your diagram, take a look and see what kind of information you have. Looks like we're given a side and another side with the included angle. So this is going to be an example of side angle side case. Since you're solving for the missing side A, I would use the equation listed at the top here. And that's how you choose your equation. You look at the information, you're looking at the variable you're solving for, and since you're solving for variable A, you should use the cosine rule that starts with a squared. And I always recommend starting by identifying which formula you're using, because once you have done that, all you have to do is plug in the given information to find the missing A. So A squared is going to be left as a variable because that's what I'm solving for. B is 12.9, so 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 with cosine of angle A, which I know is 42.3 degrees. And now this is when you will use your calculator to evaluate the right-hand side of the equation. If you put in your calculator, a squared will equal to an approximate value, and this is going to be about 109.69977 and so on. I'm going to write out at least up to 4 or 5 decimal places, because the more decimal places I include, more accurate my answer will be. So then for my last step, I'm going to square root both sides, and my A value will be approximately 10.5 centimeters. Of course, we know that when we square root a square value, our answers are always plus or minus, but this is talking about side length of a triangle, right? And side length can never be negative, so we only have our positive value of 10.5 centimeters. And that's the example of side angle side case, which can be solved using the cosine rule. For the second example, I have already drawn the diagram for angle ABC and the sides ABC. Looking at my diagram with the given information labeled, this is going to be an example of side, side, side case. And if you have 3 sides of a triangle given, you should be using the law of cosine. In this problem, we're finding the measure of angle C. And since you're solving for the variable c, you should be using the cosine rule that starts with c squared. And that's c squared equals a squared plus b squared minus 2ab cosine c. I'm going to write out the equation or the formula first, and I'm going to substitute all of my given information into the equation. For this problem, you're going to notice that the angle C is left as a variable, and that's okay. That's the information you're solving for, so you can leave that as a variable. And once we solve this equation, you will be able to find the measure of angle C. So if we evaluate each square value in our calculator, you should be getting the following values. So you should get 445.21 and 90.25 to 52.81 minus, and if I multiply these 3 values, I get 302.1, and I'm going to leave this as cosine C. Then I'm going to add these 2 values, which will give me 343.06. And now we're going to subtract both sides by that 343.06 to both sides. Then you should be left with 102.15 equals negative 302.1 cosine C. Now we're getting close. We're going to divide both sides by negative 302.1. And we're going to be finding the value of cosine C. Before you put this in your calculator, I'm going to leave this in a fraction form, because if you divide the 2 values and write your answer as a decimal, then you will have to approximate. And if you approximate an approximate value, your answer just becomes less accurate. So keep it as a fraction. Then for your last step, we're going to have to undo the cosine function, and we do that by taking inverse cosine to both sides. Then that allows to find the value of C, which now is in calculator ready form. So this is the exact answer. But we are going to actually put this in our calculator, and the value of C will be approximately 109.8. And I rounded to 10th place. Since this is finding a measure of angle, I'm going to put a degree symbol there, and that's my final answer. So that's the example of psi case, and we solve using the cosine rule.